We're reading a basic translation problem. And somewhere in there, it says the phrase, a number. What should we say a number is represented with? A variable. Now, does it matter if Mason picks an X and Mitch picks Q because he feels sorry with it, and Owen decides each time he's going to draw a picture of a cat? No. I mean, Owen's probably going to take a little bit longer if he's doodling a cow each time, but whatever. Right? It doesn't matter what you pick, but if we read something that says a number, we need to be translating that into a variable. If we read something that says the same number, you are using the same variable you already picked. So you can't read a number and pick X and then read the same number and pick Y. Once you pick the letter, you got to commit to it. Okay? The phrase is represents an equal sign. So anytime we're seeing anything with is, that's an equals. Anytime that we see the quantity, this is a huge one that students miss all the time. The quantity tells us that we need to group something together. In math, we typically group things with parentheses, so most of the time that means you have to have parentheses. If you're not sure, put parentheses anyways. Because sometimes we don't write them even though they're actually there. I would truly read this as the quantity of x plus 2 divided by 4. Do I see any parentheses? No, but are they here? Yep, where are they? Okay, so if you're not for sure, write them down. You won't be wrong writing them, we just don't have to have them. When we are translating a word problem into an algebraic expression or equation, if there's an is, you always are going to translate in the order that you read. Okay, so if you read a phrase, whatever you read, you'll write it down. There is one thing that tells us to change the order. Okay, the word than tells us to change the order. Now, it tells us to change the order if we read less than or if we read more than. Okay, but more than is addition, and does the order of addition matter? No, so if you miss it with addition, it's not a big deal. If you miss it with subtraction, it's a problem. Now, good news, we already talked about this at the very beginning of the trimester, right? We talked about this less than piece and how it changes the order. Yes, right? Are we alive? Yes. Is there life in this classroom?
No.
We're all dead?
Yes.
We've been mostly dead all day.
Yes.
Do any of you know what movie that's from? I'm very old.
Yes.
Okay, less than is telling us that we change the order. Okay, there's one other one, and we also talked about this at the start of the year, and I'm always a little bit hesitant to say it. Less than, my students forget all the time, and they write it the wrong way. Subtracted from, my students do correctly without me saying anything. So then when I tell my students that you need to change the order for subtracted from, they start changing it back to the incorrect order because they were doing it correctly to start with. Okay, so subtracted from is another one. Okay, then I have a table underneath here that's starting on your front page and then goes onto your back page of some of the key terms. These first ones we've talked about, right? We did this at the very beginning. Sum, more than, plus, increased by, multiplication of, products, times, like these are all things we saw. Agreed, 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 agreed. We're agreeing. Can I at least get a head nod? Can I get some form of life? Okay. Subtraction we did. Division doesn't get a whole lot. Division is the little loser operation. These are the four that we maybe need to take a closer look at that we haven't done a ton with. Now, we did say at the very beginning that less than was subtraction and is less than was the inequality symbol. So you'll notice every single one of these have an is in front of it. Because that's what tells us that we need to go into the inequality symbol word. If it's just is by itself, it's equals. If it is with some information about the sign after it, it's an inequality sign. Put it away. There are 2 clocks on the wall. Just put it away. Okay, if we are then looking at a cup, this one straightforward, this one straightforward. There's a couple of them though we want to make sure we're okay with. Okay, so is at most. The students often think this is a typo here. Okay, but is at most is less than or equal to. So if I say, I want to buy something, I'm going out with my friends, Mom and Dad, will you give me money? They say, how much? And I say, well, at most I'm going to need $20. Would it be okay if your parents gave you $19?
No.
Does that meet your rule of at most 20?
Yes. At most is a suggestion.
Right? At most is kind of a suggestion. Right? Less than or equal to $20 is meeting that requirement.
Yeah, I'm pretty sure at this age, if we say at most, we mean give us $20.
Right, but it doesn't actually mean that.
Well,
Okay?
personally,
Because
I just say
same
at
thing
least.
here, if you say it's at least $20, how much does something cost? $20 or more, right? So these wordings seem a little bit flip-flopped. Same thing with is no more than, right? It's not more than, so it's actually less than. Okay, is no less than, it's not less than, so we actually mean greater than. Now, you're gonna get this whole table so you can use it to translate, but when it comes like, realistically, it would be nice for you to not have to go back to this table all the time to translate. I guess if you want to Google it for the rest of your life, whatever. So, today our goal is to know these key terms and get over the first hurdle, which is that we won't freak out every time we see words. Okay, now, one of my biggest frustrations with teachers telling you to reread something is that really actually that's not a super efficient way to solve a story problem. I mean, yes, you need to read it, but usually what you need to do is break it down. Don't read the whole thing all at once. It's too much information for our brains to process. In fact, we want to just look at one tiny piece at a time. So if we look at this first one up here, the sum of a number in 67 is negative 34. What is the number? Okay, don't think about the whole thing to start with. Start in small pieces. The sum. So in our brains we go, okay, let's translate this like we're learning a foreign language. What does sum tell us in the math world?
Addition.
Addition. So we're going to write down an addition sign. Is this the same one that your guys have said?
Yeah.
Okay, I wanted to make sure I pulled up the right one. All of a sudden I thought, oh, maybe I got these confused. Of a number. What does a number tell us to write down?
X.
A variable. So what letter would we like to pick today?
X.
X, we're okay with X? No one feels really sorry about Q or something?
Nope.
No? Okay.
No,
So we'll stick
no.
to X. We're good with X. And 67. What are we going to write down there? 67 is equals negative 34. So what does it mean when it asks us the question, what is the number?
What is that?
What is X? Solve for it. So what are we going to do to solve this?
Subtract 67.
10, 11. Negative 101? And realistically, the only thing that matters is the negative 101 because the X was just a letter we picked. Number 2, the product. What does product mean? Multiplication. Now here's a little trick about multiplication. Whenever we're dealing with any type of story problem and we know we need to use the multiplication, I say to hold on to that multiplication in your head. Because multiplication's a little bit finicky. What are different ways that we can represent multiplication? A dot. How else? Parentheses.
Put them next to each other.
Nothing. We need to do some more reading to figure out what type we need to. And usually it takes care of itself. Okay? Of 8. So what am I going to write? And a number. What am I going to write for a number? Did the multiplication just take care of itself? Yep, sure did. Okay, if it wants it to be parentheses, we'll usually read the word the quantity. Multiplication usually takes care of itself and you don't need to write anything additional. Or at most. Oh, here's a weird vocabulary thing. This sounds weird to my students. Or at most.
Less than.
So at most means what?
Less than or equal to.
Less than or equal to 216. And my students are like, Mrs. McKinney, this is a typo. What are the numbers? That is not a correct conjugation of our verb here. Why does this say what are the numbers instead of what is the number? How many solutions is this going to have? Infinite, because how many solutions do inequalities have? Infinite. So it is asking us to solve this.
27.
216. X is less than or equal to 27?
Yes.
I think it's somebody's at the door.
Oh,
Fair enough. I could be wrong, but.
that's okay. It could be next door too. Sometimes we hear next. Oh,
Hi, is now a good time to borrow Mallory Hopper?
She's not here.
Okay, thank you.
Yep.
Sorry about that.
no, you're fine. Number 3. 5 less than a number is less than twice the same number increased by 25. What are the numbers? So let's do this one slow here. 5 less than. What does less than tell us to do? Switch the order and what operation? So is that 5 going to go in front of it or behind it? Behind it because we're switching the order. Again, you guys are acting like dead lumps on a log today. Can you at least give me a thumbs up, thumbs down? Can we get that going on today? You're just all fine. We're just doing okay? A number. What am I going to write for a number? Z. Oh, now we're starting to feel bad for the other letters. Is less than. What am I putting for is less than?
Less than.
An inequality symbol because this one has the is. Twice the same number.
No.
2x.
Plus 25.
Increased by. Okay, let's all solve this. Let's get it solved before we leave for lunch. Your x is greater than negative 30. We're going to do an activity to practice these when we come back from lunch.